Okay guys, welcome back. So in the last video I mentioned as to how the three important derivations regarding projectile motion or parabolic motion can be achieved by using the simple linear equations of motion. So I told you that I will make a simple example in order to understand the equations of motion and in order to further understand projectile motion. So here's the question. So this question refers so it will be easy to read. Okay. So the question is, an object is projected at a point 60 degrees inclined to the vertical and at a velocity of 30 meters per second. So the question asks to find the maximum height achieved by the object, the range of the object and the velocity of the object at 4 seconds. So it's a very simple question if you just resolve into its parts. Okay. Now the question is asking, an object is projected at a point 60 degrees inclined to the vertical. So first of all we'll draw a diagram so that it will be very easy to understand what's going on. Alright, so say a part like this, right? So I'll take the object to be here and it's saying incline 60 degrees to the vertical. Now this is not to the horizontal, this is inclined to the vertical, so we have to resolve it into two parts here, right? And the velocity is 30 meters per second, so this is 30 meters per second, and this angle is 60, not the angle between the velocity and the horizontal. It is 60 degrees inclined to the vertical. Alright, so I'll take this 60 and they are asking what the first question is, what is the maximum height achieved by the object. Now you can find the maximum height achieved by the object directly using a formula. That is something you can do, but I will use the normal general equations of motion because this is a sum. I will explain it and then explain it how you can substitute the values and find it using the derivation that I found in the last video. Alright, so this is the part. So I have some part like this, a parabolic part. I'll take this point as A and this point as B, and this time as t equals 0 and this time as t equals t, right? And B is t equals t, and the maximum point will be here C, and I'll take the maximum height to be h. So h is the first question. What is the height of h? What is the value of h? That's the first question, and this is time t equals something, right? So to find the maximum height achieved by the object, we don't know the time taken by the object to cover from A to B. So if you know the time from A to B, if it is t, you know, and as in the last video I explained that if the time taken by the object to move from A to B, from the position it is being launched to the position where it is hitting the ground, is t, the time taken to reach the maximum height is t by 2. So if you know t, you can find h easily, but you don't know t, so you have to find a linear equation of motion in which t doesn't come. So there is only one equation of motion, so that is v squared equals u squared plus 2as, from which the height h can be taken. So in order to find h, we need to understand whether it can be put in the first case. So we know that velocity v, so you know what is initial velocity u. The final velocity will be 0 here. Final velocity will be 0. Final vertical velocity, right? It will still have a horizontal velocity in this direction. The final vertical velocity will be 0. So v is equal to 0. Then 2 times a is equal to g. A is equal to minus g actually, because I will take the positive direction as if it is going above. So the gravitational acceleration will be downwards, so it will be minus g, the acceleration will be minus g, and the height is h. So we know what is v, we know what is u, we know what is a, so we need to find h, so we can easily put that equation. Alright, I'll take the motion from a to c. Considering the motion from a to c, I'll put v equals u square, v squared equals u squared plus 2as, the upward direction, right? So the final velocity is 0. Initial velocity, now this is 30, and this is 60, so this is now 30 cos 60, 30 cos 60. So cos 60 is half, so 30 cos 60 is 15. So the initial velocity is 15, so you need the square of that, so initial velocity squared equals 15 squared. So g is minus g, so 2 times minus g times h is minus 2gh. So this is minus 2 g, is I will take g as 10 and s is equal to h. So this is a very simple equation, just you need to find h here. So this is 20h here, 15 squared is 225, so h is equal to 225 by 20. So here is 5 times 45, 5 times 4, so that will be 11.25 meters. 11.25 meters, so that's the maximum height achieved by the object. Now, this is the maximum height achieved by the object if you find it from the linear equations of motion. So if you use that, the derivation that I derived in the last video, I can say h equals v square sine square theta divided by 2g. Now, I told you not to memorize this equation, h equals v square sine square theta by 2g, because theta here is not equal to 60. Theta is the angle I took as the angle between the velocity and the horizontal. So theta is not equal to 60, theta is equal to 90 minus 60. So theta here is 60. So I took, when I derived h equals v square sine square 2g, v was the velocity here 30 here, and theta was the angle between this velocity and the horizontal. So angle between this velocity and horizontal now is 30 degrees, because this is the horizontal direction, this is the vertical direction. When this is 60, the whole angle is 90, so this angle should be 30 degrees. So sine theta equals 30. So we have to find h, so we can substitute. That's why I told you not to memorize that one, because you will mislead when the angle is changed, or when it is taken the vertical angle, or the velocity is something opposite. So v equals 30 square sine square 30 divided by 2 times g is 10. So 30 squared is 900, right? 30 squared is 900. Sine 30 is half. So sine 30 squared is half square, that is 1/4. 2 times 10 is 20. So 20 here, 900, that is exactly 45. So 45 times 1.5 is 45 divided by 4. Again you will get the same answer, divided by 25. Get the same answer, 11.25 meters. So h is the same answer, it should be the same at both instances. So that's the maximum height achieved by the object. So the second question is, what's the range of the object? To find the range of the object, you need time t. So to find time t, we can, I'll directly find time t from the equation that I derived, because it's very easy. T equals 2 times v sine theta by g, right? So that's one way. So I'll work it out in both ways if you are not following the final the last video. So t equals 2 times v times sine theta by g. R is equal to v square sine 2 theta by g. So you don't need actually t, you don't need t. You know the value of r from this equation. So v equals 30 squared sine 2 times theta. Theta is the actual angle I told you here. It is 30, not 60. So 2 times 30 is 68. This is sine 60. This is not because sine, we are taking it as sine 60, not because the angle is 60. It is 2 times the angle. So the angle is 30. that the angle between the velocity and the horizontal is 30, so 2 times the angle is 60. So don't misunderstand, the angle is 60. So angle we are taking because it is getting 60 because we are taking 2 times the angle. So sine 60 divided by g is equal to 10. So 30 squared is 900. 900 divided by 10 is 90. Sine 60 is root 3 by 2. So 90 times root 3 by 2 is 45 root 3. 45 root 3. No, I will not simplify the value. So R is displacement, so this is in meters. R equals 45 root 3 meters. Right? So R equals 45 root 3 meters. So the next question is, what is the velocity of the object at time t equals 4 seconds? So to understand that, now if you are taking an object that is going in this direction. Okay, so this is the note from the last lecture. Alright, so the velocity here is v and this angle is theta, this is the maximum height h, and this is the horizontal displacement, or I call it the range r, and the time here, the initial position where the object is projected, t equals 0, and the time at which the object hits the surface, t equals t. So you know that t equals 2 times v sin theta 2 times v sin theta by g. So I told you the time taken to reach the maximum height is half of the sine, half of the time taken for the object to go from the initial position to the final position if it is on the same horizontal plane. If it is on the same horizontal plane, alright. So if the velocity, now if you are taking the velocity of an object, that is moving in gravity, under gravity, when it is going from the initial position to its maximum height, the velocity will be increasing and it will be in the positive direction. If I take the positive direction to be the direction in which I am projecting the motion, in the upward direction, the velocity will be in the positive direction, but the velocity will be decreasing and it will reach 0 at the maximum height. So at the maximum height will also, before it turns up to the other side, before it is returning back, at the instant it reaches the maximum height, still the velocity will be in the positive direction. And at the maximum height, it's actually a very infinitesimal time. You can't actually find the direction of motion at that time. So at even after a microsecond or even a nanosecond after reaching the maximum height, it will come down. The object will come down to the initial position, and in that direction the velocity of the object will be increasing. Whether we don't need actually whether the velocity of the object is increasing or decreasing. What I am going to tell you is that if an object is moving under gravity, now this doesn't affect if the object is moving not under gravity. That means if the object is moving in the horizontal direction, this doesn't mean. So if the object is moving in the vertical direction, if it is going from the initial position to the maximum height, the direction of the velocity will be positive. Whether it's increasing or decreasing, the velocity will be positive. And if it is returning from the maximum height to the initial position, the velocity will be negative. So we need to find out whether the velocity is positive or negative in order to find out the direction and the actual velocity of this object. So in order to find that, as I mentioned, we have to find whether the object at time t equals 4 seconds has reached the maximum height, or it is still between the initial position of the maximum height, or it is between the maximum height and the returning path to the initial position. So in order to find that, we have to find the time taken by the object to reach the maximum height. So as I mentioned in the last video, time taken by an object to reach maximum height if it is moving in the same horizontal, between the same horizontal plane. If it is moving in the same horizontal plane from the initial position and the final position now in the same plane, if the time taken by the object to reach the maximum height is half the time taken by the object to complete its motion. So if t equals 2 times v times sine theta by g, you can understand that the time taken by the object to reach the maximum height is v sine theta, the half of that is v sine theta by g. So you can easily derive it from the linear equations of motion as well. So I will not use them. Excuse me. So I will only use the equations of motion in that respect. So t equals v sine theta by g at the maximum height. So t equals v sine theta by g, that's the time taken for the object to go to maximum height. So velocity of this object is what's it, 30 meters per second times sine the angle theta. Theta is the angle between the velocity and the horizontal direction, so the angle will be 30 divided by g. G is equal to, I'll take it as 10. So this is 3 times half is 1.5 seconds. Alright? So I'll take the velocity as say 2 seconds. It will be easy otherwise. There will time 2 seconds, right? Not 4 seconds, 2 seconds. So it will be easy for me to explain you a new concept. Actually, what I am meaning by this problem is explaining you a new concept, right? So I'll draw this, and the maximum. So this is the time taken by the object to reach the maximum height. So what's the velocity? What is the time taken by the object to reach the initial position is 2 times this, so that is 3 seconds. So the object at 2 seconds will be between the maximum height and the initial position, so that the object is in the returning journey. Right? So the velocity here is 30. This angle is 60. This way. Here to here. So here t equals 0. Here we found at c the initial velocity, the vertical velocity is 0. The time is 1.5 seconds. Right? So it is in the returning journey. So at this point the time will be 3 seconds. So at 2 seconds the object will be somewhere here. So the horizontal velocity of the object doesn't change because as the time changes, the vertical displacement of the object changes, but the horizontal velocity of the object doesn't change because the gravity doesn't affect the horizontal velocity of the object. So horizontal velocity will be the same. So horizontal velocity here is 30 sine 60 in this direction. So in order to find the velocity of the object, we need the vertical velocity of the object. So if the object is in the returning journey from the maximum height to the initial position, its velocity will be directed downwards. So I'll take some velocity here, v, and the final velocity will be, final velocity is actually the velocity of the object as seen by if a person is on this object, if I put a person on this object, the velocity of the person or the velocity experienced by the person will be Vr. So you know by vectors Vr is equal to V square plus 30 sine theta square, the addition of that, root of that. So here we need to find what is Vr. We don't have to, the question has to find Vr, but we have only 30 sines, we have only the horizontal component, so we need to find V in order to find Vr. So to find V, I know the velocity of the, now I know only the time of this object, so this is t equals 2 seconds, right? So this is t equals 2 seconds, I need to find the velocity V here. So I don't know the height of this object. I know only the horizontal velocity and the time taken by the object, time actually taken by man. If this is 1.5 seconds and the maximum height, the object has traveled only 0.5 seconds between the maximum height and the initial position, maximum height and the position into which we are considering. So only 0.5 second displacement has been taken place from the maximum height to the place we are considering. So we don't know the height, the height of the object at t equals 2 seconds. The only thing, and we have to find v. So in order to eliminate h, I will find there's only one equation in which the height of the object is not taken into consideration. So that is v equals u plus at. So the only equation that I can put to find v is v equals u plus at, because I know what is u equals 0 and a is equal to the gravitational acceleration. So the object will be moving downwards. So I take the downward direction as positive. So then the velocity of the object will be positive and the gravitational acceleration will be also positive, because the gravitational acceleration is in the downward direction. So the velocity will be positive. So I know time t. So from v equals u plus at, from the now I'll take this position as b, and this is a and this is b. I'll take this position as e. So d. Right? This is a, the initial position. The final position of the object for the whole journey will be b. The position of the object at maximum height will be c, and the position of the object at t equals 2 seconds is d. So considering the object's motion from c to d, I will put v equals ut in the downward direction to find v. Alright. From c to d, I put v equals u plus at, this direction. So the velocity v here is, the initial velocity is 0, so I not put 0 here. So v equals at, a equals g now, because the velocity and the gravitational acceleration is positive, because I am taking the velocity, the quantities, the vector quantities in the downward direction as positive, so the gravitational acceleration will be positive. So the object will be accelerating. Accelerating is the object will be increasing its velocity. So gravitational acceleration is g, so I'll take g as 10. And the time taken by this object to move from c to d. Now I don't have the time. Now time 2 equals 2 seconds is the time taken by the object from this initial position. From this initial position, going up all the way to c and then coming back to d. So that's the time from a to c. From a to d is the time taken by the object as t equals 2 seconds. Now I am considering only between c and d. So at time c, I have already traveled 1.5 seconds, and at time d, I have traveled 2 seconds. So the time between c and d will be 2 seconds minus 1.5 seconds, that is 0.5 seconds. So 10 times 0.5 seconds, so that is 5 seconds, 5 meters per second. So the velocities of the object will be like this. So in this direction, this will be 30 sine 60. Now I found this because the horizontal velocity of the object doesn't change. It will be the same as 30 sine 60. So sine 60 is root 3 by 2. So 30 times root 3 by 2 is 15 root 3. So this is the horizontal velocity is 15 root 3. And the vertical velocity is downward in this direction. So that is I found as 5 meters per second. Right? So this is 5. So I need to find VR. So to find VR, I will take the sum of the root of the sum of the squares of these two velocities. VR equals to the root, positive root of 15 root 3 whole thing squared plus 5 squared. So root 3 squared is 3, 15 squared is 225, 225 times 3 is 675 plus 5 squared is 25 and the positive root of it. So 675 plus 25 is 700, root of 700 equals root of 100 times 7. So root of 100 is 10. So the velocity of the object the final velocity, actually the velocity of the object as experienced by a person on it, as experienced by this person on it, if a person, as I mentioned above, is on this object, the velocity of the object as experienced by a person is 10 root 7. 10 root 7 meters per second. Right? So the final velocity will be 10 root 7 meters per second. So that's the velocity at time t equals 2. So those are the only questions that will be that was asked in this question. So what I'm going to tell you is that if the velocity of an object is being asked by some question in projectile motion, first of all you need to find out whether the object has reached the maximum height or not, or whether the object is still between the maximum height, between the initial height and the maximum height, or at the maximum height, or between the maximum height and the final position. So because the velocity of the object changes and the direction of the object changes. Now in this question they didn't ask about the direction of the object. Now if you ever ask about the direction of the object is actually, I will take this angle as alpha. Angle as alpha. You have to find alpha. So I will find tan alpha first. So tan alpha equals 5 by 15 root 3. So that is tan alpha is 1 upon 3 root 3. Right? Tan alpha is 1 upon 3 root 3. So alpha is equal to tan inverse 1 upon 3 root 3. Right? Alpha equals tan inverse 1 upon 3. So you have to find 1 upon 3 root 3. You have to take the inverse of 3 times root 3 and then find the value, and then take the tangent, the tan inverse or the arctan value. So this is also equal to arctan 1 upon 3 root 3, arctan value over tan inverse value, and then find the angle. So if you were to find the angle, if the object is between A and C, if the object is between the initial position and the final position, the velocity, the direction of the object, regardless where it is between A and C, it will be in this direction, because the vertical velocity will be in this direction and the horizontal velocity will be in this direction. Vertical velocity will be in this direction, horizontal velocity will be in this direction. So the final velocity, the resultant velocity, Vr, will be in this direction at any time t. Between C and B, the velocity of the horizontal velocity of the object stays in this direction, but the vertical velocity is flipped over 180 degrees in the downward direction. The resultant velocity of the object is this direction, not at t equals 2, t equals between any time between t equals 1.5 and t equals 3. So if you were to find the velocity of an object at some time in projectile motion, you need to first understand where the object is, and then you have to find the initial velocities or the final velocities of the object at that time. The horizontal velocity will be the same, but the vertical velocity changes according to gravity. So then you have to find the vertical velocity. You already know the horizontal velocity. You have to take the resultant of that and find the velocity, the resultant velocity. Alright. So in this video, I was talking about a special sum, and in which I explained a new concept for finding the velocity. So in the next video, I'll be talking about the polar coordinates of velocities, and then the projectile motion using polar coordinates. So thanks for watching this video, and see you then.